Hi everyone, I'm Martin and welcome to another great edition of Astronomy for Beginners. Now, for the past couple of months I haven't really launched a video as much because I've been busy due to work commitments. A lot of events have happened, including my son's wedding. You know, I had to do a lot of things sorting out and I've been really busy, really hectic and all that. But I haven't forgot you guys and girls. Alright, I've done a lot of research. I had a lot of requests from a lot of viewers suggesting other plans to make a project for certain cameras, for example. I had a suggestion from Tony Pegg about reference a cooling modification for a 1100D, for example. So I did a lot of researching, a close look into it, and I've found a possible solution. Now, as you can remember from my last video, this was featured for the 600D. This is my last modification, the DSLR modification, cooling mod, and so far I've been happy with the results, the performance it's been giving me. It's cooled this camera down to lower the noise, helped to improve my images, especially for my long exposure images of the deep sky objects, for example. And because of DSLR cameras that are very noisy, when you increase the exposure times they get really noisy, pixelated, and what the cooling modification does will help to lower the temperature on the sensor as possible so that you get a lot less noise in the images. Although you've still got to take DROKs, which you do anyway for CCDs, for example. So this modification proved very successful, and over the past year now I've been using it. It's been reliable, it's been solid build, I had no problems at all. And testing it out during the peak of summer in the hottest temperature up in Scotland, it still managed to perform. It's minus 11 degrees below the ambient temperature. So really superb modification. Okay, it does have one or two perks. It's not as effective as compared to a CCD, but what you're getting for the price of the modification, costing a mere £30 to about £50 to make, you can get really good performance out of this cooling modification. So what do you expect from a budget style camera taking astro photos? And as you can see from part 3 from my last video, I show you how good it performs with the resulting images I've been getting. And so far I've had no problems with the dewing, I had no problems with the getting moisture in the camera, because I've designed this camera in such a way that you're not stripping out the camera components out, you're not breaking into seals and risk of the warranty of your camera. With this camera being made in such a way, moisture does not get into the camera. Okay, you do have to do a few adjustments, you do have to do a few precautions when you bring the camera in from the cold, okay, into a warm room. You've got to allow it to warm up and allow the moisture to evaporate. Once you follow this procedure, which is in part 3, there's no problems whatsoever, and I've had no problems with the sensor or anything, and this has been working at 100% all the time. So with suggestions from Tony Pegg, I looked at developing not just a DSLR camera. I designed a DSLR cooling box. Now the cooling box is designed to fit the 600D, the 550D, the 450D, the 1100D, and maybe some 1213Ds. So if you're the owners of those cameras, you can make this project. Alright, and I've done a lot of working out the sizes, and again, cost is a big factor for most people. Designing and building these things costs money. So the whole idea of this video is set in parts. I'm afraid they are very long videos. I wish I could condense it into one video. Unfortunately, because it's a bit of a big project, I can only do it in a few parts. So here's part one, and it took me months to try and develop. I did make an initial DSLR cooling box, but it didn't work out very well, and yes, I did waste a bit of money. So the whole idea is I had to rejig my design. So if you see any differences in the video where you think, well, why is there an extra hole there, or why is this there? The main reason is I didn't want to waste a lot of money. I just used the existing box, and I just had to learn to adapt, learn to fix other items instead. Because my last project was a bit of a disaster, and to be honest with you, it only achieved below -3 degrees below ambient temperature, which to me was pretty poor. And considering I spent literally like £40 already trying to get it as it was, I wasn't happy, so I wasted that bit of money. So again, I reordered, I had a rethink, and I developed a cooling box now, which I'm now happy with, which I'm now confident that you can undertake yourself without having the hassle, researching. All you gotta do is a few links, where the parts you're gonna need, and just make the project yourself. And believe me, it's definitely worth it. And this project, please feel free to undertake this project. As you're watching through the video, please hit the like button, okay? A lot of likes, alright? We want to see a lot of likes in this video, okay, as we progress through the series of the parts of this DSLR cooling modification. So I need your support by hitting the like button. More updates you get of latest videos coming out in the future, alright, giving you great ideas for astronomy. So that's enough of that now. So now what we're going to do, we're going to take a closer look on this video. So enjoy. So these are the tools and the equipment you're going to need to carry out your DSLR cooling box. Now first off, we're going to start off with is you're going to need something to mark with a permanent marker pen, okay, there. Then you're going to need some cutting implements like a razor sharp knife or a plastic cutter, okay, like these two. Highly recommend that you look into having some tin snips. These tin snips are very capable of cutting through copper sheeting. Okay, very handy for trimming down the copper plates. Then you're going to need a BA or cross point or small cross point, number 1, number 2 size cross point screwdriver. Then 2 stumpy cross point or flat point screwdrivers, very handy for some difficult situations which you're going to see. A longer cross point, again this is optional. Then you're going to need a 3/16 Allen key. You're going to need to have a 8-inch file, smooth file. You're going to need a set of needle files of various sizes, a marking tool kit for marking out measurements, particularly when you're drawing out your design, an engineer's square, very useful, making sure that you're cutting your items, marking down your items nice and straight. A vise, very useful for clamping down your work and your project. A junior hacksaw, series of drills bits from 2mm to 3mm, 4, 5, 6 and 8 and 8.5 drill bits. I seriously recommend that you use some eye protection. Okay, so if you're working with materials and you're cutting down materials, I highly recommend, it is advised that you wear some eye protection like these safety glasses. Then a soldering iron, some masking tape, some sandpaper or emery cloth, bit of Loctite, which is like this screw lock. Okay, very handy for Loctiting screws you don't want to lose. This is optional. Now if you've got power tools to hand, it is seriously recommended that you use them, because it's going to make your job not just easier but also quicker in the process. I use a Dremel tool like this with series of tool bits, with a sanding disc, a cutting disc, a grinding disc, and a 2mm milling drill, and a trusty electric drill. And finally, the last item you're going to require is some silicone cooler paste for heat sinks. So the parts you're going to need to require to meet your DSLR cooling modification. First off, you're going to require is this. Now this is a 0.7mm thick copper sheet, which is 400mm in length and 300mm in width. Very thin stuff, and it is quite expensive. Now the reason why I got the copper one is that copper tends to be a better heat conductor than aluminium. The whole idea is I want to try to maximise as much of the cooling as possible, so I'm going to make this project out of copper. But to keep prices down, alternatively you can use aluminium. It'll just work just as well, and it's half the cost. The next part is this. This is an ELECTROMART ABS electronics project box. Again, size dimensions is 177mm in length by 120mm by width and 83mm by height. It comes with a few BA screws, okay, so you can secure it with the top lid like so, okay, and it snubs quite fitly. Like again shown in my other last video, this is the ABS plastic box, electronics project box enclosure. The next part is this. Now this is just a small 40mm fan with a 10mm depth heatsink. Now the reason why I got this is I do like how it's got little external screws. Now this is going to be the internal fan inside my cooler, and this is going to blow out cold air. It doesn't have to be a high power fan. This is used to circulate the cold air. Now as you can see here in this picture here, the fan is actually turned on the opposite way. So the fan blades, when this is operated, the fan's actually going to blow out that way. So the fan's actually flipped upside down. And the way you can tell is if you see these guards here, you can just see the guards and you can see the exposed cable there. Okay, the fan blades are upside down. That's going to blow out cold air. Again, the heatsink size and dimensions is 40mm by 40mm, okay, square. It doesn't need to be a heavy duty heatsink unit. Again, 10mm in depth. Right, this is just purely going to blow out cold air. A few more items that you're going to need to build your product. These little parts. First off, you're going to need this, really important. This is a copper 3mm thick by 40mm and by 4mm square copper plate. Now This is relatively expensive, costs around about £3. You can buy aluminium plate, that's just as good, but I'm going to make my project out of copper because copper is an excellent conductor of heat. It's better than aluminium. Costing wise, if you want to keep it in the budget, then I advise you to get the aluminium squares. Plus, aluminium is easier to work with than copper. So I cut this down to size. Now if you can get one that's at 40mm square, brilliant, it saves you a lot of time and a lot of hassle. The next one you're going to need is a 1/4 1/2" bolt. It's an Allen bolt. This is going to be used to fix underneath my camera main body. It's also got a washer as well. Then we have metric 3 tiny screws there, a metric 3 thread nuts, and then you've got printed circuit board spacers. These are standoffs, and these are to fit the metric 3 thread. They have an internal female thread inside, and these brass standoffs are going to be used to fix my circuit board onto my temperature cooling circuit. These are metric 4 countersunk, they're 20mm long, and these ones here are just cut down to 15mm. You can get them in 16mm, which would be okay, but I've cut them down to 15. If you look here, there is 3 aluminium 6mm diameter. They are 10mm long, and these are cut off from an aluminium rod. Okay, so they've already cut down, ready to go. And with it, you need 6mm O-rings, which will fit over those little buttons there. So you're going to need 3 O-rings that fit 6mm diameter, and you're going to need 7 tiny screws. Now these are, I think, the 3mm screws. They really are tiny screws, but they're self-tapping screws. Okay, with a Phillips drive. Doesn't really matter what type of screws, as long as they are no longer than 10mm, you should be fine. Very reliable piece of kit. It is the DROK micro digital thermal temperature controller circuit board. Okay, with a waterproof sensor probe there. Okay, there's a sensor probe. I'm not going to highlight too much detail on this item because it's already featured in my last video guide on my last Canon DSLR modification. So I'm not going to go too much in depth, but overall I'm going to use the same temperature controller circuit board. Really fantastic device, and it's going to be used again because it's so reliable. Okay, my last modification, I've had no problems with it, so it really is a decent piece of kit there. This is optional, but I would strongly recommend that you buy this item anyway. Right, and what this is a dummy battery coupling. Now this fits a Canon 600D. Alright, this DC coupler fits an LPE8 battery. Now, depending on your camera of where you're going to fit it, you're going to have to buy the matching dummy battery to fit your Canon camera. Okay, so I know the 1100D takes an LPE10, I believe, battery. And this is an E8 battery for the 600D. So get the right coupling, the DC coupling. And what it is, what it enables you to do is you can connect your camera and you can connect it to an external DC power source. Okay, they cost around about £15 brand new. But believe me, you'll need this item. Strongly advised, because when you build your cooling box, believe me, you do not want to be changing batteries, especially when you're imaging. because if you are imaging, it means you're going to have to disconnect the battery, all the leads, take the camera out of the box and replace batteries. This will stop that from ever happening. It's a quick, easy fix, and it'll save a lot of time, a lot of issue, and you will not be losing valuable imaging time. So this is strongly recommended that you buy this item. Okay, it's over the budget. I know it's an optional item, but £15 is definitely worth it. But it's up to you. If you want to keep costs low, then by all means. But I'll guarantee you, when your batteries die out, you don't want to be taking your camera apart from your cooling box just to change a few batteries. So, top tip, get one of these items. We've got a sheet of clear perspex. Again, you only need a little bit of this. This is around about 2mm thick, okay, sheet of perspex. You don't need too much material. You're only going to be using maybe 3-inch rectangle of that, so you don't need a lot of perspex to require. So again, you're going to need some of that. So the next part you're going to need is this. Now this is a 12 volt 6 amp DIY electrical semiconductor refrigerator radiator cooling equipment. The size of this dimension is quite big. Okay, the length is 235mm in length, 140mm in width, and 115mm in height. Now this is quite a big unit, okay, but basically this is a complete setup of a Peltier cooling system. It has twin fans, okay, you have one drawing the air coming through from the input and a fan that's reversed drawing the air outwards. And basically this goes through this radiator, which when the Peltier cooler gets hot, you see there's copper pipes here where it will extract all the heat, and the fans will dissipate that warm air. And what this system will do, produce a very efficient cooling system. If you notice in some of the clips further on in the video, you'll notice that I have made extra holes on the box. I've realigned another different heat sink and fan. They didn't work. Now this is plan B. This is my new idea, okay, and hopefully this proves to be successful. My last cooling system didn't quite work as I expected, but with this setup, this will maximize and extract all that heat as quickly as possible. Again, it has a Peltier Tech cooler, which is a 6 amp Peltier plate in between the heat sinks. Okay, so you've got the cold side and the hot side. Okay, and the plate is in between there. Okay, it's powered by a 6 amp, so it gives out plenty of cold air. And again, it's got all the wires for the fans, okay, and the Peltier itself. Okay, you will have to rearrange the fans when you line up your Peltier cooler into the box. Okay, so you will have to unclip these quick clips here. This all comes out. Okay, if you squeeze those clips there, okay, this is attached to the radiator. Okay, you unclip these clips. Okay, they've all come off. Okay, and these fans come out. Okay, these fans come out, and it will also give you access to unscrew the mounting bracket, which is held in by a metric 4 thread bolt. Okay, so you will need to, if you want to readjust or position or tighten up the refrigerating system onto your box, you'll have to take the fans off and tighten up the bracket.
Okay, so that's a whole setup for that. This costs around about £18, okay, £18 and 78p, which is the cheapest I can get, okay, but it's got everything you need, okay, and it's quite an easy, it's quite light as well, it's not very heavy, okay, I would say it probably weighs around about 400 grams, alright. I did use a different cooling system. It wasn't as effective that I expected. The last one that I did only achieved below 3 degrees below ambient temperature. So with this beast of a cooling system, I'm hoping to get a lot more better results. One thing I will have to sacrifice, okay, you will need to have a smaller heatsink for the cold side, because this heatsink sticks out quite a bit, for about a good 25 millimeters sticking out, plus the fan, which is a 10mm fan. Okay, you will have to replace that with the smaller heatsink. Okay, still the same 40mm fan. Okay, so you can still use the fan, but the heatsink, because it's quite big, I will go for something slightly smaller. So again, you'll have to take this apart. There will be some copper thermal paste in between there, so just be careful because it'll be a bit messy. Okay, but that is the refrigerating system. So here's the few parts you're also going to need. The other parts you're going to need is the metric 4 nuts. As you can see there, you only need 2 of these, and metric 4 washers. Now the nuts and the washers is going to be used in conjunction with your refrigeration system. Now with the standard refrigeration system, the main remaining bolts that clamps onto this cold side heatsink, and it's threaded. Okay, so because of that, we're not going to use this heatsink, alright, because it's too big. We're going to use the existing bolts. We're going to use nuts, metric 4 nuts and washers to attach the refrigeration system onto our DSLR cooler box. Also, you're going to need some terminal block sets, right? These are junction connections, which is a 10 amp and a 3 amp connectors. Okay, basically what this enables you to do is to connect series of wires together and then form a wire onto the temperature controller circuit board. Now reasons for that is you're going to need some wire. Okay, this is 0.6mm copper wire. Okay, this can withstand up to 10 amps of power. Okay, these wires, again, they're color coded. You only need a small amount of wire. This is too much wire I've got here. This is around about 3 meters. You probably only need about half a meter, if that. I've got 2 sets, one in black, one in red, so it's color coded. So when I wire up my circuit board and my electrical circuit, I know which one's the positive and which one's the negative. Red being the positive, black being the negative. Okay, so I color code it myself, and this will be used to wire up within these junction boxes onto my temperature controller circuit board. Again, you can use them. For the fans, however, you're going to require this cable. This is a 3-pin, and this is a part for a CPU fans. Okay, this operates 3 CPU fans. They have female ends, okay, and it has 1 male end. Now, the reason for this is with the refrigeration system unit, it only has a 2-pin adaptation here. Okay, just a red and black cable. Now there's 3 of these, so you've got 3 fans on the refrigeration system. This has been one of them. Alright, and you're going to connect, this one will make it a little bit easier. Instead of trying to cut this off apart, these are very easy to just connect this onto the cable. You can fit them onto a 3:2. You just line up the pins, okay? Alright, line up the pins, and again, with a bit of line up the pins, which is red and black, and you just line it up like so, and it clips in. Alright, there you have it. I tried to find a 2-pin wire loom like this, but I couldn't find one. So this was the only one I could find. Now I would be interested if you can find something alternative, a CPU fan, a 3-way splitter cable like this. If you can find a 2-way splitter cable, that'd be fine. And again, this fits. Alright, you just got to line up the pins, find out which one's the positive and negative, and you just line them up. Okay, it feels, and then it just fits in there. Okay, alright, nice and secure. Reason why I went for this method, because one, it's easier and quicker to connect all the fans, plus you're going to reduce amount of cutting wires and having to resolder all your fan circuit together. It's up to you. Again, if you want to cut the wires and solder them up using wire, that's really up to you. Alright, but again, this is an optional item. It only costs about £3 for a 3-way CPU fan splitter. And what I do is I join all that lot. This is just a 2-wire adaptation. Alright, here I will just cut this end off like so, and this will be attached onto the male end like so. So it then goes into 1 wire, okay, like that. It just makes it a little bit easier to attach all the fans together without having to cut wires, resolder them, and so forth. So the next item is this. You can use a 5 amp. This is a 5 amp cigarette adapter, which is a 12 volt or 24 volt with an on and off switch. Okay, it's got a 5 amp fuse, and again, it's a thicker wire, a lot more robust. Alright, now I mentioned in my last video, you're going to have to cut this wire, okay, and fit it onto the circuit. And the easiest way I found out is to purchase a 12 volt DC 2.1 female DC power socket, which you can attach it onto your project box. Okay, and here you're going to need a 2.1 millimeter 5.5 jack plug onto here. Okay, so again, you're going to have to wire it and do a bit of soldering. So again, fitting that plug, it's just going to make it easier to plug in your power cable in and out. Okay, so it's well worth getting that. Get yourself one of them. I do like the on and off switch on there. Okay, and it's not much money. So that's the electrical parts and mechanical parts you're going to need to make your cooling modification. The next item you're going to need is this. Now what this is a big roll of floor insulation. This is 3mm thick. Okay, it has like a foam sponge lining, and then it's got a thermofoil. And this layer thermofoil is used for like carpets and stuff like that to keep installation and all that. And the reason why I got it is because of this aluminium foil. It reflects some of the cold heat in, so any form of heat on this side will get reflected back. So, and that's what I'm trying to do. This is going to be my installation, okay, for my cooling box. So what it's going to do, as well as speed up my cooling, it's also going to keep that cold heat in there and keep it maintained. So we've got your project box. This is going to be the box I'm going to be using to put my DSLR camera. Now I picked this box because it's ideally suited for any budget style DSLR cameras. Again, this can fit the 600D, and it can fit a lot of other cameras like the 1100D, the 450D, the 500, the 550D, I know those cameras are that kind of range. I don't know about the 1200 or the 1300D, but I'm guessing they're very similar sizes, and I'm certain that all those cameras will fit in there. But it's a little bit bigger than normal, okay, but it just fits. Again, it fits snugly inside this box. It does pop out slightly, okay, but it fits in that box nice and secure, okay. So that's why I got that box. But in here, I think it's perfect size. Now, the good thing is about this box is I'm going to do some alterations. I'm going to cut parts of the box so that here you're going to have a part here where you can have your T-ring exposed here. So when this camera does fit flush inside the box, it'll be nice and secure. Alright, it's not going to go anywhere. Alright, like always, now if you look at my diagram, I made a little template and I did a lot of measuring, and I basically made this template. This paper template, which I will provide the link of my template design, this will fit inside here, okay. That is my template made. Again, please refer on that diagram to get all the sizes to measure it up for this template. This fits inside the box perfectly, okay. I've done a lot of messing around, done a lot of mass work into this box, okay, and this exactly how I've designed. Now this template is going to be the cooling plate. This is going to be a massive cooling plate, and with this template, okay, I basically cut it out after I've just drawn it. Then I get my 0.7mm thick aluminium plate, and guess what I've done? I've draw around using permanent marker. Don't need to be spot on, because if you're slightly out, you can always cut it down slightly into shape. Alright, I've put in my fold lines so that when I bend this sheet over, it's going to give me the rough shape of my plate. So it's a huge plate overall, and I have not marked out any holes, because the whole idea is it will become apparent when I show you later on. What I would recommend is that you use, if you're going to cut metal sheeting, is to use a hacksaw blade, cut along here carefully, and then file it down evenly. If you've got power tools that can cut through metal, like a jigsaw or any form of power tools that will cut sheet metal, I would recommend that you use that, because it's going to make your job just a tad easier. But again, if you don't have them, just use a hacksaw blade and just carefully cut it out. I've come up with my plate like this. As you can see, you can just see the size now. I've just bent one side over, as you can see there. Okay, it matches the template. Okay, so as you can see there, that is my copper plate halfway there. So with this, the reason why I bent this side first is that what I'm going to do is I'm going to place the camera. Okay, so when I mount it inside my box, the camera's going to sit here. Okay, and I'm going to start to place some markings along the particular areas where the lens cap is going to go, and where this part is going to stick out, and where the mounting 1/4 bulb bolt is where it's going to be situated. So that's why I made that first part first. But before we mark out any areas of the plate, to make it easy, we take the plate to one side, and basically we have the box. Now, first thing if you notice, if you can't see that, but just in the strong light there, you can just see I've just made some markings. Is used my 40mm heatsink set up. Because it's almost the same diameter as the Peltier cooler, I place it over like so. Don't matter which way you want to put it. So basically I just place it bang on in the middle like so, in a roughly in the same position of the bigger heatsink. So once it's centered, you then score a line across, okay, like so, all the way around till you get a nice perfect square. So what I'm going to do is I'm going to cut that out. So as you can see here, I've drilled all the way through using a 3mm drill bit on my Dremel. You can use any other drill, okay, and what I've done here is I've drilled all the way around, okay, in series to give me a rough shape. As you can see here in that picture, is it's still within my square, okay. So now what I'm going to do is I'm going to use my Dremel milling tool to just mill out this square. So after a lot of cutting and filing, I've got my square that I need. Okay, that's nice and square. So I've got my copper plate, as you can see, I've done a lot of filing and I've done a lot of bending. Again, to get it to this shape, I had to use a vise. You can bend this by hand because the copper is very thin. You've got to look at particular tension to these parts here around the corners. Okay, the idea is you want this copper plate to be flat on the base inside your box lid. Okay, again, if it doesn't fit very well, okay, you just got to keep filing it down. All right, filing it down, rebend it, and just keep going it until it fits nice and snugly like so. As you can see here, there is a bit of a gap between each of the plate sides, but that's not to worry, because the whole idea of this design is you need to be able to feed the cable through the gaps, okay, and also have some insulation in between there. Also, you notice here up that side, because it fits nice and flush, I've marked out the areas. I marked out my mounting screws, okay, and I've basically marked out the holes, okay, either side, okay, and it's given me a position where I'm going to mount bolts through there so that it will hold this plate firmly in place on the actual plastic box itself, making it a much more rigid format. The other thing to point out is, okay, if you notice some parts of the sides are not quite parallel, okay, that's probably due to me bending it not adequate enough, or there's too much material. As you can see here, there's material exposed there, but do not worry about that. The main focus is better to have too much material than too little. So the whole idea is once you've got a rough shape like this and it fits flush at the bottom and flush adequately along the side here where the Peltier cooler is going to be, alright, then you shouldn't have to worry. Alright, so if you do get access to material, just quickly file down or cut along the sides so that once it's nice and straight and it's level inside that plate, you can put your lid onto like that. And you're going to have to do a lot of cutting, a lot of filing. It's a long process, but it will get in there. And the whole idea is this plate should fit snugly. There is one important factor you must consider now, and it's very crucial that you get this right. This is probably one of the most difficult parts of making this box. Is what you're going to try and do is, as you need to mark out the area where your camera nose piece or your T-ring is going to expose from. Again, to mark out the area, you're going to have to get your camera, it could be any of your cameras, your 1100D, okay, take it out and place a T-ring with a 2-inch nose piece adapter, okay. Now you can fit an 1.25" nose piece adapter, it's really up to you, but I would highly recommend that you use a 2" nose piece adapter, okay, and basically you can just fit it snugly in place. But there is a catch, and the problem is though, is you've got to try and mark out that nose piece inside using a pen and mark round where that nose piece lies. Now please take your time, it will take some time to mark it out, but it's very crucial that you get this right. And all it's going to do, when I cut this out, I'm also cutting not just the copper plate, but also I'm cutting the plastic box, because this nose piece has to protrude outwards through the box. So it is nerve-wracking, but if you get it right, this will make the project seem a lot easier. So that's what we're going to do. So that's what I'm going to do, is I'm going to mark out my nose piece position, where it's going to lie, okay, and once I've got it marked, all I'm going to be doing is I'll be drilling out with this single holes, that single hole method, and then jigsaw that entire area. So marking out my position of my nose piece, and it is, as you can see, it is quite tricky. So I've marked out almost half of the circle. If you can't make a complete circle, do not worry. The main thing is once you've got half a circle, that's half of the battle. So what you're going to do is take out the camera, and as you can see there, we've got half a circle there. Alright, so what we're going to do is we'll take out the nose piece, and then we're going to carefully place the nose piece above where I've just marked. Okay, and then what we're going to do is we carefully hold it in position and then draw the rest of the circle. Okay, like so. So now you should have a rough circle there. That is the position where the camera is going to go now. So, right, so this nose piece, once it goes through there, this will go straight through the box. Okay, but we're not going to drill the box yet. We're going to cut out the metal plate first before we drill the outside of the box. So as you can see there, I've done a lot of drilling, and I've just used a 2mm pilot hole around my circle, just underneath the marking. Okay, I don't want to go over the marking, because then that means I'll make my hole a lot bigger. Now the one thing to make it address, that you can use a T-ring hole. Okay, so you want the T-ring to expose fully out that way. However, on this design, I just want my nose piece just protruding through, right, and that's all I need. Also on the side, I've drilled out my pilot holes where my main heat sink's going to go. Okay, so that's going to clamp in there for extra security. There will be some more holes drilled through the plate, but that will all become apparent further on. So what we're doing now is I'm going to use my Dremel tool. You can use a junior hacksaw or something that you can get in between there. Okay, or you may wish to just drill a bigger hole and use a jigsaw or some sort to try and cut all the way around that circle. But again, this will come off eventually. Okay, you just got to do a bit more drilling. Alright, and then once this is removed, I carefully now just use a file. Okay, use a file and just smooth out and make a perfect circle. Okay, so that's very crucial that you get this right. Okay, so don't rush. This will take some time, but you will get there. So after a lot of drilling and a lot of filing yet again, we've now finished the hole, as you can see there. Again, the good thing about this plate is if it don't fit perfectly, you can always just slide it in there in place and then readjust it. So that is our case, nice and snug, okay, and we're going to score a circle inside the case to give me a rough shape. So now I've put out my circle, okay, for my nose piece to come through on my camera, okay. I've got my 600D, okay, and now I can fit my 2-inch format nose piece straight through. Okay, it is a tight fit, okay, but it will go through. That's it, and as you can see, really good fit. Now, one thing I do need to highlight in particular. Now, if you're just going to use just the camera with a standard 2-inch nose piece, it's fine. However, there is one slight problem. If you're going to use a chroma corrector, for example, like this one, or you're going to use a photo reducer and field flattener on this camera, okay, you may come to this problem. As you take it out, as you take the other camera out, okay, you'll see this. We remove the field flattener and photo reducer, and as you slot it inside, okay, you'll see that the actual nose piece and the actual, you can see where the T-ring is and where the photo reducer thread is. You can't thread it through. Also, you're increasing the air gap, which means if you're increasing the air gap over 1 millimeter gap, it's not going to work. You're going to get errors in your images, obviously curvature and all that. So the only way you're going to do this, if you want to fit a photo reducer on your airbox, then the only possible solution you're going to have to do is you're going to have to take out the copper plate, and then what you're going to do is get your photo reducer, what I found out is that you can either, because it's quite big, you're going to have to feed it from the bottom side. Okay, so you're going to have to feed it at the bottom side. Shove it through the nose piece itself, and then carefully, without damaging any components, as you see here, you just score all the way around the circumference of your photo reducer. Okay, so when you take it out, you can just see an outline of the actual shape of the photo reducer. Alright, you can just see that. So then what you're going to do is you're going to machine that out using a Dremel tool, or you can use a file and just file that down all the way to that edge, okay, of your complete diameter of your photo reducer. And that is one way to do it. Yes, I totally agree. What you'll find is that this is reduced, yes, but don't forget this is 0.7 millimeter thick. That's the reason why I got this plate, is because it's still within the limits of 1 millimeter, because that's how photo reducers and field flatteners work. As long as you're within 1 millimeter air gap, plus or minus, either way, the field flattener or photo reducer is still going to work. Okay, and that's the reason why I got this plate. Alright, so it's well within limits. The other thing is, you can alternatively, if you want to reduce the air gap, you can get 0.5 millimeter plate, which again, they help to reduce the weight. plus reducing the air gap even further. But I think 0.7 is more than adequate. So that's something to highlight there. Alright, so if you want a fuel flattener or photo reducer to fit the airbox, you're going to have to make this bigger, okay, in order to achieve it. Now, the other thing I also notice is even when you're fitting your plate, if you fit the camera through the nose piece, through the hole, however, it's at a slight angle as well, alright, and you don't want it to be a slight angle. You want that camera to sit in there properly with no interference, okay? You want this dead straight. So as I'm pushing it forward, that's where it's dead straight. But one thing I've noticed, the reason why it's like that is if you take a closer look, you notice that here on the actual flash housing, it sticks out. This part sticks out a bit, and it sticks out a good maybe 2, maybe 3 millimeter outwards. It's same for the 1100D, but again on the 1100D it's much more prominent. It actually sticks out even further to about 5 millimeters. So the trick is though, you want the camera to sit properly and not at an angle. So this is why if you grab your plate, now I found it was very hard to measure or to mark where that position of your flash housing must be situated. So what I did is I got some masking tape, masked all the way across the actual housing itself there, and then what I did, I sort of cheated. What I did was just use some black paint, paint it carefully, don't get it all over the camera, okay? And if you are painting, make sure that your covers are covered up, and I just paint along. And in a way, what I did, I just basically put the camera carefully, and as I slot it through the hole, like so, I just quickly press down using this part here, press it down, side to side movements, and then once I've finished, I just carefully pull it out. That gives me a rough estimation of where the flash housing is going to be. So that is one way to do it. Now I tried to mark it while it was in situ with a pen, but it didn't work. So this was the better option. Now I know the rough estimation. What I'll do is then I'll cut out this part, drill a few holes, and then just carefully, you can use a Dremel or use a file or needle files, and just quickly file that out and file out a nice hole. Okay, so that's what I'm going to do now. So after a lot more filing and drilling and all that, I've finally got my shape. Okay, so when I stick my camera through here, okay, it fits into the hood, okay, and it sticks out, gives a bit more space, and now you can see there it's a lot more, it's closer to the plate now, okay, nice and flush, and that is exactly what I want. Okay, so that is that done, and as you can see here, I've made this shape this bit more. I've just filed this a bit more, okay, give me a bigger circle with careful filing, okay, using needle files and all that. Okay, so I slot in the copper plate, it fits nice and flush. Then as you can see there, you can see it's slightly bit bigger, okay, through the hole, and then we're going to stick the camera inside. Okay, it takes a bit of a while. We then get our photo reducer or chroma corrector, either one you have, okay. And basically the whole idea is you keep the camera nice and straight and just feel for it, okay. And as you can see, screwing it's as you can see now, it's starting to screw in nice and neat, okay. And that's a good fit. That's exactly what I want. As you can see there, nice tight fit, and as you can see there, that's exactly what I want. Nice airtight seal so that no frosting can get out, okay, and also maximise, because it's a decent seal, that will maximise the cooling. And the good thing is I can still attach my 2-inch nose piece. Now the other thing, because where I've bent the metal, it's not quite in there, okay, so you might need to just push in the material just a bit. And as you can see, you can just see now there are certain areas where it's protruding. So what you're gonna have to do is you're gonna have to draw the markings, okay. Draw the markings where the metal sticks out, okay, and you just draw a line across. What you're going to do is, once you've drawn those lines, you're going to then cut the edges down so it's nice and flush within the case. And that's what you're going to have to do. After finishing off your plate, making sure that everything fits, the next stop is, as you can see here in this plate, I've marked out a 8mm hole, okay, on the plate. That's where the camera 1/4 bolt will screw on here, okay. Then I've made like another hole for another screw to fix in there. So what this is going to be is, this plate's going to be well secured, okay, inside the plastic box, so this is not going to flex or anything like that. Again, you can make these holes a little bit bigger when you're mounting your main heater cooler. These are 5mm holes, and these tiny holes are around about 2mm. Now the reason why I've only just put 2mm screws is I'm using this tiny 40mm heatsink and fan, okay. They're going to be on there. Now, as I described to you with these tiny screws, okay, these are very tiny screws, and basically what I did before I do anything, I placed the screws in there through the plate, and then what I did was chop them off or grind them down, and I should have tiny screws like these, okay. The reason why I ground them off, because they were sticking out, so I rather just grind them off. Because the screws were sticking out, I mean, I would like to have liked to screw these on the plastic base, but because the Peltier plate is very close by, I didn't want it to screw through there and cause damage to the Peltier cooler. So to prevent that from happening, I just grind down these tiny screws, okay. They should screw in now. So to prep it up, it's very crucial that you clean the area where the 40mm is going to be. So we're cleaning it up with a bit of polish, using metal polish, okay, only a little bit, you don't need to do too much, and you're just going to clean that area. As you can see, there's a lot of crap that's come off this, all this tarnish. Ideally you should really clean the whole plate itself, okay, but this is just for demonstration purposes. Using a duster or a cloth, just quickly just buff up, clean up, polish that area, okay, best you can. So now, as you see there, where I've cleaned that area, okay, that's nice and shiny. Okay, very important that you get your surface areas, particularly where the cooling parts are. You know, less of the corrosion, better the heat transfer through the material, okay, through the metal. So it's very crucial that you get a little bit of polish just to clean it up, get rid of any corrosion. And then what we're going to do is then get ourselves some silicone cooler paste, okay, and we're going to spar a little bit of heatsink paste over, okay, give it a mix, okay, just a little bit, and then you're just going to smear all of that all the way around our heatsink paste. Now the reason why I use silicone cooler paste is that if you smear this will go and give a good contact bond so that it can transfer the cool heat better, okay. And then what we're going to do is we're going to place the heatsink in a certain way where we want it, okay. The surface, and then we get a little bit of Loctite because of these screws being quite shallow. We're just going to Loctite these a little bit. You don't have to get this Loctite. This is Loctite 243, which is like a stud lock, okay. And we're going to put a little bit of Loctite, only a little bit, just enough so that these screws don't work loose. So we're gonna the Loctite, okay, only a tiny little bit. We're gonna position one of the screws, okay. This will be fiddly. So carefully tighten up the screws. Don't need to be mega tight, okay, just tight enough so they don't work loose, okay, just nipped up. That's that secured. Grab a cloth or some tissue and just wipe the excess heatsink grease, and as you can see now, that's the internal 40mm heatsink and fan in place. Now the other thing is, as you can see in this plastic box, I've also marked out the area where my mounting 1/4 bolt's going to be there for my camera. Here's the other screw. Now it doesn't really matter where you put your mounting screws are. The reason why there isn't any on the top, because there's going to be the temperature controller on the top, so there's going to be screws on top of there, so I haven't done them as yet, but it doesn't really matter where you place that. However, it does matter when you put in your camera mounting bolt. Now you don't have to put it in there, because if you're using the photo reducer and all that, it usually already clamps it in place. However, just for extra security of the camera, I decided to put my 1/4 hole there so that I can mount my camera like so, so it's in line. Now the other thing, if you're probably not unaware, if you can see here, you see these like ridges. What I'm going to do is I'm going to remove them by filing them down or using my trusty Dremel. Okay, so if you're a Dremel user, please feel free to use it, because this is where it's going to play handy for you. So what I'm going to do is I'm going to grind off all these securing ridges. Now these are just like where you can put accessory trays. You can divide them and so forth. I don't know why this box has it, so I'm going to grind them off. And the reason why I'm grinding them off is I'm making sure that the plate is firmly fixed onto the outside case. Also, I'm ensuring when I put my installation layer, which is going to go along here, from the bottom from the sides and the tops and bottoms. Okay, I'm going to make sure that my insulation is tightly packed in there. Okay, so that's why I'm getting smoothing out all this out, so it's all nice and smooth and straight. Okay, so that I'll be completely aware that my insulation and my fixings are going to be well secured. So I'm prepping up the area before I put it all together. As you can see here, I used just a sanding head. Alright, that's all you need to use for this job. Alright, and just to sand down those ridges. Then you will get some plastic swarf obviously in the metals, so you're going to have to use a wire brush to scrape it all out. And bear in mind, there's a lot of swarf when you're sanding down all that plastic, so wear protective goggles, okay, to protect your eyes when you're doing this. So with that, I also sanded it down even further just to smooth it out just a little, okay, and I used 150 grit fine emery cloth or sandpaper and just quickly sand it down. After that, you can just put it in the water in a sink and just wash out all the swarf and all that. So you should have something like this, very smooth, okay, and that's what you want it.
That's part one out of the way. Again, please look forward to part two. Alright, it'll be more in depth on making the actual project itself. Okay, so there's a lot to take in, but I had to do it in parts. It's the way it is. They are long. I tried to condense it, but I couldn't, because if I try to condense it, then I'm going to lose a lot of valuable information. So again, please hit the subscribe button. If you like my videos, please hit the like button. We're also available for Astronomy for Beginners Facebook page. Please join that group. Okay, we've got a lot of good knowledge there from a lot of beginners and experienced amateur astronomers, alright, out there helping people get into astronomy and getting those fantastic astro images. Not just astro images, but also helping people able to study the night sky and achieving their main goals in spotting the deep sky objects and planets and the moon and other things related to astronomy. So again, it's not just for astro imaging, it's also for community, for the people who have a telescope and would like to take up astronomy. Again, that's what that Facebook group's all about. So again, please, if you like my video, please hit the like button and please subscribe onto my channel. Again, keep you updated with the latest hints and tips and product reviews. So again, thanks for watching, and please look forward in watching part 2.